Hello, Jordan. Fourth floor, can you come here, please? Yes, they do. Hello, Jordan. Mithun here. Mithun here. Fourth floor, can you please come? Okay. Okay. Good morning, everybody.
Good morning.
Good morning,
Good morning, sir.
Good morning.
Good morning, sir. Should we get started? Is everybody there?
So a couple of students are yet to join.
Sorry?
Sir, few students are yet to join.
A couple of
Voice
students
is
are yet
not
to
audible,
join.
Chirag.
Sir, few students are yet to join.
Okay, I'll just wait for a couple of moments.
Sure, sir.
Sir, before we start, Krishna, this side.
Can you please come again?
Can you hear me?
Yeah, now it's slightly better.
Okay, sir, I have a request to extend the deadline for assignment submission.
Yeah, sure. That's okay. No problem.
Yeah, because this week I have only been able to go through the lectures 2 and 3.
Interesting. You can take some more time. That's not an issue, but just when you're doing it, just be mindful of all the expectations and then try to do a good job.
Yes, sir.
Okay, fine.
Mithun sir, this is Anand here. Hello.
Anand, please. Anand, please.
Yes, sir. So we tried actually what you have shared, but still I was getting error
Can you please,
whenever.
can you please share your screen here? We'll just try to look at what you have.
Will do, sir. No, yeah.
Okay, just give me one moment.
So is my screen visible?
Just 1 second, please. 1 second.
Yeah.
Nidhi Agarwal is waiting in the lobby. Okay, what have you done? Pandas version you checked. Okay. Okay, execute that code, please. 1 second. Let's see. Wait. Is the first one executed?
Yes, it's running. It's running. It's just running.
Okay, hold on.
Hello.
Yes.
Shall I run this, sir?
No, is the first one, do we know the version of Pandas firstly? I don't think the first code itself is run now.
First code is not running. Yeah.
I think it is caps V. Just check the version. It is caps V. Just check with pandas dot double underscore version. Second line. Yeah.
Okay.
Print inside the print. I think it should be caps V. Just check that.
No. While in the class, this was running actually. When I was trying to
pandas as PD, so it is not pandas dot version. It is PD dot double underscore version. PD dot.
Okay.
See, pandas as PD is the alias name for pandas.
Okay.
Right. So you should in this under the print statement, inside the print statement, don't give it as pandas. Please type PD dot. Yeah. Now again, I'm not sure about the V part of it. V. Okay, it is small letters V. I'm sorry.
Okay. Okay. This is running. So this is already done actually.
Okay, 1.3.5 is what you have, which means it's a higher version, so you have to downgrade it. Now, one of the first things that you need to do at this stage is use in the next line exclamation of pandas install, pip install pandas is equal to 0.25.
Yeah.
Pip
So
install panda.
at that
Yeah.
time, while I was running it, so this is the error that we are getting. So.
Yeah. So you must restart. You must restart the runtime in order to, okay, restart runtime, click on that button.
Shall I give
Yes,
it?
yes. Go up, please scroll up. Okay, first line anyway you can run. It is not important, but we can run the first one, that's pandas version, whatever. Yeah. Okay, now you run this install wala thing.
This one, right, sir?
No, yeah. Second, yeah.
Okay.
Pip install. Okay. Now, so these two things are wait. Now the third thing that you need to do is uninstall an existing version of pandas profile. So what you can do is exclamation. This is the next line of code. Exclamation pip install -u pandas profiling.
Yeah.
You can run this. Yes.
So this is like hyphen only, right? Not underscore.
Yeah. It is hyphen only. Yeah.
Okay.
Scroll down.
So
You must restart. Okay, let us restart it. Not a problem.
Yeah.
Yes. Just scroll up.
So I have to run everything again, sir?
No. Yes, start with that pip install pandas is equal to 0.25. Second line of code. Yes, we need this, right? Wait. Yeah. Now you install pandas profiling. Wait. Let this code run. Wait. Okay, so it says successfully uninstalled the higher version. So successfully installed pandas 0.25. Okay, it seems okay. Let's scroll down now. Okay, skip this. Now you come to, once you install that, now you can do one thing, which is import pandas underscore profiling.
Yeah. Here comes error. This one. So yeah, this was the error that I was getting before also. Hello, sir. Can you see the screen?
I can. Do one thing. Have you done this pip install pandas profiling? Go one step behind this. Yeah. Now you execute this one code. Yeah, please. Please execute this. Pip install. Yeah, -u pandas profiling.
Again, it's asking to restart. Shall I restart?
Sir, I executed this similar kind of step 3-4 times yesterday, but still I was getting that soft error something.
Soft code, yeah. Soft Unicode or something. Shall I restart the runtime again, sir? Or
Yeah, I think you can start fresh here because here.
I will restart. So
Older version.
yeah. So from where should I run, sir, again? Pip install pandas. Should I do it again?
Yeah. Try this.
Okay.
So this is the foundation. The foundation we have got it right. Okay, so this itself install. Wait. Can you just close this session and open a fresh session of Google Colab?
Yeah.
Just a fresh session of Google. Just close this entire thing.
Okay. So I need to make a new notebooks.
Yes.
Or
We can just open a fresh, completely fresh notebook.
yeah.
That's okay. Title is fine. Just start typing those. If you have, do you need the codes to copy paste? Otherwise, we'll be. So in the chat window, I'm just pasting some of these codes.
Okay.
So chat. Let's try with the first one.
Haven't got. Oh, okay. Yeah.
Earlier it was working, is it?
In the class it was working. No, what happened now?
Okay. The first line of code.
Yeah. I didn't get copied.
So this pandas profiling is slightly tricky. You get a lot of errors. And it has got nothing to do with the syntax. It's got something to do with the compatibility. So lower version usually should support pandas profiling. Control enter also we should do instead of you clicking there, just control enter.
Okay. Shall I try the second one, sir?
Okay, just 1 second. Just go there. Just show me the error message. Pip's dependency resolver does not currently take into account all the packages that are installed. This behavior is the source of the following dependency conflicts. Which is incompatible. Google Colab requires pandas greater than or 1 point.
It doesn't stop us from doing the next steps. You can continue. I to get, but subsequent stuff work.
This should not prevent us from installing pandas profiling. Yes. Okay, please go on.
Yeah. So
Karthik is waiting in the lobby. Admit. Successfully installed. Okay. Just try importing pandas profiling now.
yeah.
Girish Kumar.
Sometimes I see new names in the sessions. Is Grish part of this batch?
Yes, sir, we have given the access.
Okay. Okay. Anand,
Yes.
just above Mithun's chat, I had posted one line. Can you try that?
Yeah, sure.
You can install markups safe. Is
Aniti,
it?
I think you also were talking about this. Yeah. So I Googled, sir.
Oh, is it?
Yeah. So few people have reported about the version of this module or a package markup safe. I think a particular version have to be called. Before installing the your pandas profiling, try doing that, Anand.
Okay. Before installing. Okay.
Yeah. I think you have to restart and then do the pandas profiling installation now.
Yeah. So installation importing, right? This one I have to run now.
Now,
No,
now you try.
entire thing. Yeah. I think
Entire
I
thing
have
from the beginning.
entire thing I have to do. Yeah.
So Ganesh, that markup safe, that should be the first step before even installing this 0.25
Let me
version.
check my code.
Okay.
Let me check my code. Yeah, I have installed pip install markup safe and then imported pandas profiling.
Okay.
Let's see whether it works. Scroll down.
Yeah, it worked for me.
Okay. So now I have to run this thing again, or I can just
No,
import
no.
it now.
Import pandas profiling now.
Yeah.
There's a problem.
I'm getting the error again.
Okay. Did you run the markup safe?
Yes, he ran. He was able to run this.
So after restarting, I didn't run.
Okay. You run the pip install markup safe and then you import pandas profiling.
Yeah. It's again asking
This is
to
fine.
restart. Yeah.
You must restart the route.
This is fine. Now you try the.
No, it's coming. It's the same error again.
Okay, Anand, I will do one thing. I will just maybe sit with you separately. I think there is some silly mistake that we are doing somewhere. We have to just look at it. But don't worry too much about it as of now. We'll begin with today's class. Okay.
Sure,
I'll sit with you maybe some other time. I'll just sit with you. Okay.
Okay. Thank you, sir. Yeah, I've stopped sharing screen.
Yeah. That's it. Okay, guys. Shall we begin with today's syllabus, guys?
Yes, sir.
Yes, I'm assuming that everybody is there.
Yes, sir.
Pranish is there. He's joining online. Pranish Srivalsa.
Guys, we are on the way.
You're on the way. Okay, no problem. Okay, fine. No, not an issue. Not an issue. Okay, fine. Okay, guys. Today is day 4. Can we just quickly recap whatever things that we have covered, guys? One of you. Important things which we have covered. You don't have to go in depth of everything. Just give me a high level perspective of some of the important things that we were able to pick up. Day 1, day 2, day 3, day 4. Right? Yes. It's okay. Get started. Not an issue. It's, whether it's right or wrong. Don't worry. Get started. Krishna.
Sir, I can say about day 2 and day 3.
Okay, day 1, I think somebody else. Just a high level perspective. What did we do?
Yeah. So in day 2 and day 3, we covered chi-square test.
No, hold on. Let's begin with day 1. Guys, why are you so silent? It's very simple. We just, the first session, if I recall, we covered about the fluid methodology, wherein we spoke about 6 different steps. right? What are the six different steps we will take? And then we spoke about the application of data science, some of the important terminologies and such things at a very high level. We discussed what is supervised learning, what is unsupervised learning, some of these techniques which we discussed at a very high level. That is about session 1. Then we moved on to session 2, which was about exploratory data analysis, mainly EDA or exploratory data analysis. What is mean, what is median, what is mode? We use the describe function, right? We try to learn, about missing values, those sort of things. We ran a few graphs and such things, right? We tried bar chart, pie chart, right? Box plot, right? These are some of the things, guys, that you need to remember. At least bar chart, box plot, the interpretation of the box plot at least should be very, very clear, right? How do we compare using box plot? Those sort of things. Mostly we touched upon EDA or exploratory data analysis. Am I right? Right. Day 2, what did we do? That's about day 1. EDA, exploratory data analysis, mostly univariate statistics with respect to one variable. We were just working. Day 2, what did we do? Second day.
Started with pandas profiling, I guess. Remember again.
Yeah, we started off with the pandas profiling. We mostly try to work on hypothesis testing, if I'm right.
Sir, on day 2, we have worked on cross tabulation of the data, put some time on looking on the margins and on the percentage of it. And then it was advised that looking on the percentage across a row gives us some better impression of the reality. And
yes, cross tabulation. When do we use cross tabulation? When do we use cross tabulation? Just 2 important points about each of these things. Also, if you're able to tell, it's good enough. Cross tabulation. When do we use cross tabulation?
Sir, when we have to compare some stats about a entity or the rows.
So I think it will be more like when we try to figure out correlation.
It is mainly used for relationship, right? So whenever we want to find out relationship and such things, that's when we use cross tabulation.
Yeah. So for the calculation of chi-square, actually.
Yes, exactly. So whenever we have to look at, your chi-square and such things, I hope you remember this Excel sheet, guys. Remember, I told you that there are 2 business problems. The first is basically people may expect you to find out relationship. So how do you find out the relationship between 2 variables and such things? Right. So if the problem is about relationship and such things, you need to be very clear as to what are the kinds of variables that I have. You have 2 categorical variables or 2 scale variables. If you have 2 categorical variables, what do? You use a chi-square test. Chi-square test cannot be performed on raw data. So that's why we use this group by function, table function and such things, because that will give you the cross tabulation. In the row, you have the first categorical variable, like let's say gender. I'm just giving a very simple and a rubbish example so that it is very easy for you to understand. Gender, that has 2 categories, male and female. In the column, you can take one more categorical variable like marital status, customer satisfaction, right? Any of these things, whether a person is infected from COVID or not, whether a person is a diabetic, yes or no, right? So when you have these 2 categorical variables, that's when you can use chi-square test. Are we clear with this?
Yes, sir.
Right, guys, these things you cannot forget. You can't fumble on this, right? You should be crystal clear. What you do not know, please don't break your head about things which are unwanted or irrelevant or which might not be that important from an industry perspective, but some things which are important. If you're saying that I know chi-square test, you can't use the word compare. There you have to use the word relationship. I am trying to find out the relationship between 2 variables, right? How do I do it? Just use the pivot table function, correct? In the index, you can just use the row variable and you have you can display the percentages by changing the values in the argument, correct? So 2 categorical variables.
Sir, I have a question, sir.
Yes, please.
Sorry if I stopped your flow. So Mithun sir, Ganesha, so one question, one observation that I had is, while we use this contingency table, regardless, I mean, for example, like the stores example that we had, so we looked at row, column, table, etc. However, like regardless of what the table said, though we debated on so which store has what rating, etc. we did not do anything about what the pattern said. We still went ahead giving that like uh, the the input as for the function to take care of it, right? So, but we did not do any uh, do anything about like what we observed. Is my understanding right, Mithun?
So if I understood, your audio was slightly breaking, so I'm just repeating the question. Please just tell me whether I've understood your question correctly. So your question is basically we looked at the cross tabulation and we based our inferences based on the cross tabulation, correct?
Correct.
Yes. So see, in statistics, there are two words that we use. One is by chance, right? These two words, by chance something is happening. Second, exactly opposite of by chance is a scientific reason, right? If something is happening by chance, then we don't take it seriously. On the other hand, if there is a scientific reason, if there is a strong, compelling reason for me to sort of conclude that there is a relationship, we go ahead and propose it. So when I look at the cross tabulation itself, maybe the numbers for one store are higher, the numbers for other store are lesser. But that does not tell me conclusively whether there is a relationship or not. What tells me conclusively whether there is a relationship or not is I have to perform a chi-square test and then look at the p-value. And if the p-value is less than 0.05, then I can say, yes, there is a scientific reason. I have not used the word scientific reasons while writing. While writing, we do not use words like scientific reason and such things. But the message or the meaning behind it is when we look at the p-value, is there any scientific reason for me to believe that customer satisfaction depends upon store ID? Or are these big numbers, small numbers that we see observed in the cells happening by accident? I'm again not using the words. When we write, we don't use the word accident and such things. We just look at the p-value. Think of it like this. Think of it like, if there is a case, forget statistics for a moment, your High Court and Supreme Court. Your High Court may say a lot of things, but the final authority is not with the High Court, it is with the Supreme Court. What the Supreme Court says will be considered as the final verdict, right? The same way here, your p-value is like the Supreme Court verdict. That p-value is what we rely on. That p-value is what we go by eventually to decide whether there is a relationship between two variables or not. Because any of those numbers that you are showing in the cross tabulation may be happening or occurring accidentally, because when I go there on a particular day, I've taken the data and therefore because of a bad sample, I'm seeing these big numbers for one store, small numbers for another store. Therefore, I'm a bit hesitant to go purely by cross tabulation and graph. But graph and cross tabulation are important as a preliminary step. But I can't go to the business management and very confidently and say, boss, this is very important, or this conclusion that you see, store one, people are highly satisfied, store two, people are dissatisfied. I can't be that confident unless I look at the p-value. Therefore, we always look at the p-value. P-value is like the Supreme Court verdict that has the final authority to decide whether two variables are related. Is there a relationship? Is there no relationship? Is there a variable which is important or not? So the entire game is on p-value.
Got it. Okay, sure, sir. Thanks.
So because any of these things, so I'm just giving an example here. Let's say I go to a supermarket, right? I went to Reliance Fresh recently to get a dozen bananas, right? I went on a Monday morning or Monday late, around 11:30, 10:30, 11:30, somewhere around that I went. I picked up a dozen bananas, right? So I noticed when I came back home that there are a few bananas which are rotten, right? It is not good, right? Now, so this is what I'm seeing. I don't care about the reputation of Reliance Fresh, who is running it, not right. For me as a customer at that moment, I felt cheated that I did not get good fresh bananas. Now, based on this data point, can I conclude that Reliance Fresh and the shopkeeper there is selling me, defective products or rotten bananas, or all the time he has got fruits which are bad, right? I cannot, because that is one sample. So it is a sample specific conclusion that you are deriving, because just by one data point, I cannot make a conclusion. Now compare this example with that customer satisfaction. A person would have gone and he would have taken 1 month data or 2 month data or whatever month data, and then he's looking at the customer satisfaction, right? Now, if the entire question is basically, if you go tomorrow, if Ganesh says, boss, I don't trust any of your results, boss, I will conduct from fresh. I'll ask a fresh set of customers to give their rating at a different time point, right? So with customer satisfaction and what such things, what happens is that usually at night when you come, right? Let's say you've had a very bad day, you've not had your appraisal, and you feel cheated. Bangalore traffic, then somebody asks for customer satisfaction. People will usually give a poor rating. At a different time, maybe when you're very happy, there's a tendency to give a good rating as well, right? So all of these things are sample specific results. My question is, in statistics, basically, we go beyond sample specific results to generalizability. How generalizable? As generalizable as possible. And that is possible only when I look at the p value, because when I compare it with 0.05, I'm saying, boss, you may go to the shop 100 times and shuffle the sample. 100 times you may change the sample, do this, do that, take it from a fresh set of customers. But by and large, what you expect is that at least 95 out of 100 times, you may see that the bananas that you buy from Reliance Fresh are going to be rotten. So in that case, my conclusion will be that this shopkeeper is a fraud. He is not really giving me good service, whatever, blah, blah, blah. Or vice versa. He's an excellent shopkeeper, whatever. So that call can be taken by p value, probability value. Then you may ask, sir, why do I need to look at the cross tabulation and the and the graphs and such things? Usually what happens is that the end user may not be a data scientist. Usually the consumer of analytical results and such things, they will not have a background in data science. They will not know what is p-value. They will not know what is level of significance, what is hypothesis. They don't care. They don't need it either, right? So for them, what makes is basically you show a graph and say that I have taken this variable and store and customer satisfaction. And we found that in store 2, people are mostly dissatisfied. And we have run a few statistical tests. And based on the statistical tests, we have found that there is compelling evidence for us to believe that there is a strong relationship between the store and customer satisfaction. It has got nothing to do with sample results, because even if you change the sample 100 times, by and large, the results will still hold good. By and large, I'm saying, which means 96 out of 100 times it may hold good, or 97 out of 100 times it may hold good. 3 times the results might not hold good. But there is compelling evidence for us to believe that store ID influences customer satisfaction. So what? So basically, whichever stores are showing high dissatisfaction, you please work on that. You please spend money on staff training. You please work on improving the staff courteousness, their behavior, their attitude, product knowledge. All these things you need to improve. Other stores maybe like, let's say, Kormangla and Jayanagar, people are already doing a good job, so don't have to worry. So that kind of a statement you can make only when you look at the p value, and therefore we give highest importance to the p value, not anything else. Others we just look at, but we can't make any conclusion. Is that okay? Is that understood? P value, just focus on that value. P value is the one which has the highest authority. That is like the Supreme Court judgment, right? So you might have observed this 4 or 5 years back. I took a person to the doctor, right? He was able to look at there was a bit of a pain in the leg. He suggested a few exercises and such things. Correct. Now, after doing, he spent half an hour. Can you move your leg up? Can you hold it straight? What is your, do you have sufficient power to lift your leg up? Can you walk a couple of steps? Can you lift your, can you lift your hands up above? So he gauged a lot of, he looked at a lot of things, from how many days are you feeling this pain? Are you able to, is there a pain in spinal cord? For half an hour to 45 minutes, he asked a lot of questions. But he was not able to suggest any treatment based on just asking questions. What he is actually said is basically take a X-ray. Unless I see internally what is going on, I will not be able to make any statement and suggest the future course of action. So we eventually had to go through the X-ray, and once he looked at the X-ray, a series of medication, series of whatever treatment he was able to suggest. Why can't we, for every patient, I can't start off with the X-ray, right? The same way, if you look at the statistical comparison here, it is like the p-value is like the X-ray. That tells me a lot of details about sample repeatability and such things, which are not told by simply the graph and the cross tabulation. Cross tabulation and the graph is just like preliminary analysis. It's just preliminary. It does not have much teeth. It does not have sufficient teeth for you to make a business recommendation, right? So this is the X-ray based on which the future course of action, everything was discussed, right? The person looked at the X-ray. Is there a bone swelling? Has the bone got crushed? Which bone has sort of got swollen? Is there an internal fracture? All those things will be told by the X-ray or your MRI scan or PET scan, whatever, blah, blah, blah. It is not told by visual inspection. So your graphs and cross tabulation and such things are important. It is not important because that is just like you examining the patient physically, right? You push, you just see the pulse and such things. That tells you, that gives you certain signs and indications, but it is not conclusive. What is conclusive is the p-value, because we give the final importance to the p-value. Therefore, for relationship and such things, what I do is I always look at the p-value. If the p is less than 0.05, we we say that the variables are correlated. Less than 0.05, that is the cutoff. It means that the variables, the two categorical variables are related. That's it. If on the other hand, two variables are scale variables, right? Mileage and sales, those sort of things, right? Mileage, sales. We have discussed the types of variables, correct? Different types of variables. Mileage is there, sales is there, income is there, amount of money spent is there, number of transactions is there. All those things are nothing but scale variables. If you want to find out the relationship here, don't use chi-square, because chi-square as a test is designed to take care of two categorical variables. Correlation can be used to check whether there is a relationship between two variables or not. Last class we saw that heat map, right? X dot core of simple CORR. That function will give you the correlation value, whatever, right? If you want, you can just take it to the next level and do a heat map and such things. Or through pandas profiling also, we were able to look at Pearson's correlation and Spearman's rank correlation. So the first two cases are purely based on relationship. They're purely based on relationship. These two things are, that is chi-square and correlation, are used to check whether there is relationship or not. Now, next set of problems, business problems that you may have would be about comparison, right? So I just gave you the example of that little girl. You want to compare her performance with the neighbor's performance, which is two people. Your neighbor's the neighbor's daughter, maybe neighbor's daughter is one group, your daughter is another group. So between these two groups, between these two people, is there a significant difference or not? So when you're comparing between two groups, let's say male and female, right? Between A group, A variant and B variant, then you use independent sample t-test. Before and after for the same set of people. Before giving tuitions, what was the performance of your daughter? After giving tuitions, what is the performance of your daughter? Is there an improvement or not? Right? Before and after, whenever you have, what do? You just straight away head to paired samples retest, right? Sir, before and after I don't have. I want to compare my daughter's, let's say, midterm examination marks. Sorry, I want to compare the class average. The class as a whole has got around 60 out of 100. I want to compare whether my daughter, my child is getting anywhere near 60 or more than 60 or on par with the class. Then you can use what is called as benchmark analysis or one sample t-test. One sample independent samples, which is also called as A/B testing. And finally, you look at the paired sample t-test. So these are for comparing, right? So when we say compare, usually, t-test comes into picture. So these are the three types. So only if you are looking at A/B testing and such things, what happens there? Only two groups. Sir, I want to look at COVID infection rate across all the states. A lot of people believe that Maharashtra is the one state wherein the highest number of infections happened. Highest number of infections in India happened in Maharashtra, right? So is it true that it is I want to compare the performance across 28 states and 9 union territories. So 28 is a number which is greater than 2. Do you all agree? So I can't obviously use independent sample status. So I have to move on to what is called as ANOVA. AOV, right? If you use AOV command, you should be able to get and break it down by the different states. So when you have multiple groups, that is more than 2 groups, you can use ANOVA. Right? ANOVA, correlation, please keep these two things in mind. It's very, very useful. ANOVA, correlation. Right? This is one stage, right? First stage we completed EDA. Second stage we looked at hypothesis testing. In the third stage, what did we do? In the third stage, we looked at multivariate analysis. Day 2 was reserved for bivariate analysis mostly. And in day 3, we began by looking at multivariate analysis, wherein we built a model which is called as linear regression. Linear regression, you have to remember this. You can't forget linear regression. Linear regression is like the foundation of all other modeling techniques, right? You can learn tomorrow, you can learn all these fancy techniques, restricted Boltzmann's machine, somebody will come and teach you, or you can learn what is an auto encoder, what are some of these other methods like CNN method, all right, LSTM, long short-term memory, gated recurrent unit, all these hi-fi techniques you can learn. But the foundation, by and large, will still be linear regression. You can't forget that. Somebody will teach you decision tree. Within decision tree, you may have 145 to 165 different varieties. That's okay. Right? By and large, the formula, the flavor may change. Correct? By and large, these things may change, but the foundations will still be the same. Right? If your foundation is the same, right? I always give this example. If you learn how to drive a car, right? If you know any of the cars, it could be Santro or Zen or your Ambassador, right? The fundamentals of driving will not change, correct? Accelerator, brake, clutch will be the same, any car. First gear, second gear, third gear, fourth gear, fifth gear, reverse gear will not change. Right? Other things here and there, maybe the wiper, that this and all, they may change the position, blah, blah, blah. He may give you some additional facilities, this, that, those things will be there. But by and large, the accelerator, brake, clutch, those ideas will not change. Those ideas is what I'm trying to impress upon my audience more than the cosmetic things like, the other things. Right? The other things, how do you split the data set into training and testing? Why should you split the data set? Usually, that is an important question. So in the interview, if somebody asks, sir, what in the interview, many times, when we take interview, the question, if tomorrow somebody gives you a problem, how will you approach the problem, right? Or what steps did you take to, predict the key drivers of sales? So we built a linear regression model. We got 80% accuracy. That's what people tell, and that's the end of the story, right? So since you know data science, at least you've finished 3 or 4 modules. That is not how you should present it. What you should present, how will you present it? If I ask you this question. Just take a simple problem of sales prediction. I'm just taking very simple, right? Right. I'm not going to churn and default fraud and all. Let's keep a very simple thing. You have to predict sales. So if you have to explain this in an interview, how will you explain? How will you begin? How will you begin this? How will you begin this? Where will you begin with?
First, we'll start with data pre-processing.
Please tell me again.
First, we will start with the data pre-processing. We'll see like
no. Hold on. Why data pre-processing? Why data pre-processing? In an interview, if you say, don't start with data pre-processing at all. See, that's where I was just telling you all this while last 3.5, 4 days. The fundamental thing that you should basically impress upon is basically the fluid approach. Right? Why do I have to predict sales? That case itself is not established first. Why should I predict sales? So first you should say basically as a background, we observed that when we did a quarter-on-quarter sales, I'm just giving an example, okay? When in the last quarter, basically the sales has come down by 3.5% or 4%, right? And the management does not know which are the key drivers which impact sales, which are the key metrics which are impacting sales, right? Since my revenue has come down, or since my since the passenger footfall and such things have come down, therefore this quarter we have a target of 10% increase in such things. And therefore, to address this problem, we have to build a data science. We have to take the approach of data science. So here, if you see here, I don't care whether it is linear regression or a simple bar chart that you have built. The first thing that you should impress upon your interviewer is what is the problem statement? What is the background? Don't talk about data at all. In the interview also, many times we don't understand why have you built a linear regression. I don't care whether you build linear logistic correlation. I don't care. I'm just a businessman. I want to improve my business. So the first 2 minutes you should basically spend giving the background of the problem. That's why I was just saying about fluid. The first thing about fluid, collaboration, deployment, define and such things. We have just now talked about deployment. So you can also say that we had an onshore client, and for this particular client, we saw that people's response had come down. Whatever be the case, people's response rate had come down, and because people's response rate has come down, the mailing cost shot up. And because the mailing cost shot up, then we started making a lot of calls which are all to the wrong customers. So establish the business case first. That is the first step. Don't talk about statistics. Don't talk about data science. Don't talk about anything in the first 2 minutes. The problem state, define the KPIs, key performance indicators. Business background. Second stage is basically key performance indicators. What is this KPI? I told you just now that the response rate, if you're talking about mailing and such things, campaign mails and such things, the response rate has come down. If the response rate and such things are on par, then I don't need a model. There's a saying in United States of America which says, don't fix something which ain't broke. Don't fix something, don't solve a problem which is not necessary, right? So if the sales response rate, everything is on par, then I don't need a data science approach at all. So because there is a problem, then that question of data science comes into picture. So first thing is basically highlight the background, then highlight what are the KPIs. So this itself should take you around 2 to 3 minutes so that you can basically impress upon your interviewer. In the interviewer, this is the problem that I am after. Till here, are we making sense? Am I making sense, Nidhi?
Yeah, understood.
Yes. So this is where you can just, you can use any approach. Fundamentally, there are deficiencies with the other approach. Therefore, I'm saying please follow the fluid approach, because many of the deficiencies which are there in other methods, we have addressed it. So collaboration, define the KPIs. Now, how will you solve or how will you achieve this? A response rate of 5%. In the next quarter, we are planning an aggressive response rate wherein we want to increase the response rate, or I want to increase the sales, whichever be the problem, you can highlight this. Therefore, I'm using data science technique. Now you can see after 5 minutes, for the first time, I'm talking about data science. So data science is a solution to a specific problem. So tell your audience, tell the interviewer, what is the problem that you're trying to solve? Without that, this linear regression or bar chart or anything is just a wasteful expenditure. It's just a waste of time. Right now, you can say, even before the technique. So now to answer, to boost up the sales, I'm going back to the original problem, boost up the sales. What did you do? What you did is basically to collect data. Usually the business team, the CEO, or even the data science team, they don't understand about data. So you can say, sir, last 3 years of data is what we took to understand the patterns. Why not last 3 months? 3 months basically is not good enough. 3 months is short, right? So you're talking about data collection. We collected the data of last 1 year or 2 years or 3 years. Then use the right vocabulary and the language, right? What was the sample size? So the sample size in the data set was 2000 observations. We had monthly level data, we had daily level data, whatever be it, you can just tell, right? So what all metrics should you look at? What all metrics should you look at? What all variables should you look at? Sales, obviously you need. Date in which the sales happened, I would need that. which all campaigns were run on a particular date, you would need that, right? To whom were these campaigns sent, you would need that. Do you have any demographic profile of the customers? That aspect also you would need. So mainly demographic details, psychographic details, firmographic details. These are campaign level details. This is the way, this is the set of variables that we collected to prepare the base data, BASE data, DATA, right? So right now what you have is basically the base data. Am I clear till here? So we began. Step 1 is what? You'll be talking about the background. Step 2 is basically you'll be identifying the KPIs or the key performance indicators. Step 3 is basically the, what is it? Assemble or collect the base data. Till here, am I making sense, guys? Yes or no, guys? Yes, no?
Yes, yes.
Yes. Now the question of algorithm comes into picture. Now, not even the algorithm. Now your data pre-processing, which Nidhi you are talking about, comes into picture. Right? Data pre-processing means what? Somewhere you may have some missing value, you have eliminated it. So somewhere there was an outlier using box plot, I've eliminated it. You can talk about data pre-processing and such things for 3 or 4 minutes here. Are we clear here? 3 or 4 minutes. That's it. Missing values were there, outliers were there. How do you treat it? How did you remove it? That which variable had missing values? What is the percentage of missing cases? If it has around, if it has a very tiny percentage of, if it has barely 3 or 4 records which are missing, you don't have to break your head. But if it is around 1% or 2%, you can just use mean or whatever it is. We have discussed that, correct? Mean, median, mode. Those sort of things you can just discuss. Then your point about data pre-processing and such things comes into picture. Now, as a next step, the business might have some hypothesis. Might, I'm using the word might. Correct. The business might say, boss, there are certain areas wherein the response rate specifically has gone down. Can you please do a data analysis and tell which all areas wherein the data analysis has gone down? Right. So area wise, you can do analysis. Gender wise, you can do analysis. Right. Bivariate analysis, comparison, all those things you can do. If not, you can leave this bivariate analysis and directly jump to the modeling part, which is your linear regression, or today we'll be talking about logistic regression. Are we clear with this? There you can say, how did you build logistic regression? What is linear regression? People say they start off. One thing is basically, clear your vocabulary. Vocabulary in the sense when you're a professional, right, you should use the right vocabulary. Like linear regression is an example of supervised learning technique. We had the dependent variable, which is sales. Why did you use linear regression? He may ask. Usually people ask this question, why not logistic regression? Why not this? Why not that? Fundamentally, linear regression is the one which is used because the dependent variable is a scale variable. Therefore, we use this particular technique. Which are the independent variables? Demographic details of customers, blah, blah, blah. I use this particular technique. Therefore, we freezed on linear regression technique. And what did we do? We split the data into training and testing. Why did you split the data into training and testing? Usually the model gives very, very good results on the overall data set, but when you deploy it in a real-time environment, the model fails. Therefore, we split the data set into training and testing. 70% was allocated for training, 30% is allocated for testing. Somebody may say, no, that is not enough, right? Training and testing, I don't trust always. What is a guarantee that, training and testing, you may test, it may show satisfactory results. We are working in a very dynamic industry. I don't even trust test data. So you can say in that case, what you can do is we split the data not as training and testing. There's another way in which you can split, which is called as training, testing, and holdout sample. For the rarest of rare circumstances wherein the accuracy and such things are fluctuating. 60% for training, 20% for testing, and another 20% for testing, or 70% for training, 20% for testing, and 10% as holdout sample. Everything is the same. You'll build the model and then you'll apply the model on the test data. You look at three diagnostics. How did you evaluate? You can say we looked at R square. When you're introducing a terminology, you should know what is the meaning of R square. It is called as coefficient of determination. What is the range of coefficient of determination? Additionally, you can say we looked at MAPE, mean absolute percentage error. And we also looked at mean absolute error and root mean square error. These are the three metrics, but predominantly we focused on what is that? R square. You can just focus, you can just highlight what are the key important findings. Then you can say which are the key important variables which had an impact. How did you do your heat map and such things? What are the conclusions that you are able to draw? These are the points which you can highlight. My suggestion to you is like, there's a saying, right? If you have members of in the legal fraternity, law is a big subject, correct? You have 101 clauses. And property, a person who's into crime, murder and such things, he may not understand much about your property related issues. So a person who wins the argument is not somebody who knows every clause. A person has by hearted every law, everything he knows. He is not the person who usually wins an argument. Who's the person who wins an argument? A person who knows 10 things about a law, when it can be applied, when it cannot be applied, what are the pitfalls? That's what you should know. So even if you know linear regression and logistic regression, and there's another technique called as PCA, 85% of your real life problems can be addressed. 85. Here and there, yes, I need a fancy technique here and there, but with your linear regression, logistic regression, a bit of smartness, right? Let's say your decision tree algorithm, and at best there is a technique called as PCA. 4 techniques. If you learn properly, you can combat 85 to 90% of the problems. There'll always be a stray problem which cannot be addressed. There's always there in life, but learn these 3 or 4 techniques. I think most of your problems should be taken care of. So far, are we clear, guys?
Yes.
Yes, how the flow will remain the same for every technique. You'll be splitting the data as training and testing. Firstly, you should basically convince the interviewer whether you're learning, whether you're using a supervised learning technique or an unsupervised learning technique. Why is it called as unsupervised learning technique? What are the model diagnostics? What are the important output? Right? This much you should be clear about. Now, today's session is about what is called as logistic regression. Now, please tell me if you're able to see this particular screen.
Yes. I have one question, sir.
Please tell me.
So yeah, so I could see that we are talking about scale variable and benchmark variable. So and categorical variable, but so have we also taken into consideration parametric and non-parametric tests?
See, parametric and non-parametric, when we say, usually they come under hypothesis testing. Yes. So when we are talking about this Excel sheet, do you recall? Yes. Whatever I was showing? Yes. Most of these things, yes. Most of these things, correlation, A/B testing, T testing, ANOVA, all these are examples of parametric tests. Except your Spearman's rank correlation, which we did, which was the only example of non-parametric test.
Hello, sir.
Yes.
Sir, I have a
yes. Can I address this question first? Can I finish off that question? Yeah. I'll come. Yeah. So is that understood, right? ANOVA, chi-square, t-test, all these things, Pearson's correlation, all these are examples of parametric test. The word parameter means mean and variance. Please keep that in mind. The word parameter in statistics means mean and variance. So here we go by mean and variance, right? I have not covered non-parametric tests because non-parametric tests are for small samples, and in the industry, non-parametric tests are not used widely, and therefore I have not covered non-parametric tests. Mostly my focus has been on parametric test. One non-parametric test which is used is Spearman's rank correlation. While doing pandas profiling, I touched upon Spearman's rank correlation. Okay. Second, that is as far as hypothesis testing is concerned. At a second level, though people don't use these words in the industry, linear regression, which we were talking about, that is also an example of parametric approach. Today, when you're talking about logistic regression, that's also an example of parametric approach. So mainly this applied statistics module is the place in this applied statistics module of 4 classes, which I was training you in. I've been mainly focusing on parametric approaches only. After me, subsequently, speakers will come, different speakers will come. They will be speaking about non-parametric approach, which means basically there are no assumptions and such things. Don't have to worry about independent variables being correlated and such things. So those are all non-parametric approaches. Typically, remember 3 examples for non-parametric. 3 examples. There are 101. The first example of non-parametric approach is what is called as decision tree. Second example of non-parametric approach is what is called as SVM, support vector machine. Third approach of what is called as third example of non-parametric approach is neural network. So decision tree, support vector machine, neural network, all these are examples of non-parametric approach, which is beyond the scope of applied statistics module. Separate speakers will come and at suitable time they will cover you, right? Cover these things. So if I mix up parametric and non-parametric, there will be complete confusion. Therefore, I avoided non-parametric. I wanted to keep the focus as much as possible on the parametric itself in the 4 classes that I was addressing. Right? Okay. Decision tree I have not covered. SVM I have not covered. Other things will be covered at a later stage. Yes, please.
Yes, sir. I got your point. I agree with you then. So another observation that I'm having is with respect to the sampling. Okay, so based on the sample size, also we change the we change the testing the type of test that we conduct. So like for small sample T test and for big sample J test. So that way something can we have some.
Yes, yes. To just add to that point, usually I think while talking about pandas profiling, you can just go back and check the recording. I've emphasized this point that for extremely small samples, when you have very few observations and such things, usually you can use your non-parametric tests. But as the sample size becomes larger and larger, when the sample becomes larger and such larger, usually we can focus on some of these parametric tests. Right? If you have barely 6 values, 7 values and such things, in the internet, you can just type non-parametric tests. There are a few tests which are available like Wilcoxon test, Mann-Whitney U test, Kruskal-Wallis test, right? Which you can always use, but I am not focused too much on that, but be aware that these tests are there, right? Wilcoxon test, Mann-Whitney test and Kruskal-Wallis test. Your questions and in the examination, I'll not be asking too much about non-parametric tests, right? But you should know what is the difference between parametric and non-parametric. You should also know what's the difference between Pearson's and Spearman's rank correlation. Okay. Is that okay? Shall we begin with today's syllabus?
Yes, sir. Okay.
So today I'll be talking about logistic regression. Last class I spoke about linear regression, right? So some of the ideas that I will be covering here. Okay. What is called as what is a classification problem that I want to talk about? What exactly is logistic regression? Thirdly, model diagnostics. Just as in the case of linear regression.
Sir, for linear regression, there are few things are pending actually. So not going to cover that one.
Sorry, just a small code wherein I had to show you the what is that the p-value, how to generate the p-value. That part was pending. I'll just cover it. It'll just barely take 5 minutes.
Yeah. Okay.
Okay. So the reason I'm starting off with logistic regression is because now you're fresh Right, when you're fresh, I can just talk about a new topic so that it's a lot easier for you to understand, right? But if I talk about logistic regression in the second half, most of you might not be in your, might not be at your best, and this becomes very difficult for you to digest. So when you're fresh, I just want to introduce a new topic, right? But don't worry about that. There's just 2 lines of code that we can easily cover at a later stage. Don't worry, I'll do that.
Okay.
So logistic regression, model diagnostics, use cases, and a couple of disadvantages with logistic regression as well we can just touch upon. So fundamentally, the first point, which is about classification problem. So yesterday, when I say yesterday, last class when we did linear regression is never used to address classification based problems. You remember we were trying to predict Boston housing data set we had. We were trying to predict what? Housing price. Price is the sales variable. We were not trying to classify. We were not trying to classify. Correct? We were trying to predict the value of a scale variable. What is the expected price of homes in Boston? That is what we were trying to estimate. Correct? So linear regression and such things come into picture when you are making a prediction. Those are problems which are called as prediction problems. Right? Now, there's another category of problems wherein you are trying to sort of, which are called as classification based problems. The word classify itself means basically you want to put them into 1 or 2 groups or 1 or 3 groups. Correct? Let's say in the case of telecommunication, correct? The main problem there is about churn. Churn means people who leave from one company to another, right? Yes or no. So this is a case wherein which is called as classification based problem. Right? So firstly, you should impress upon, you should be very, very clear. Is it a prediction based problem or is it a classification based problem? So if you're trying to classify based on the images, I want to classify whether a person is expected to suffer from lung cancer or not. Yes or no? This is not a linear regression based problem. It is a classification based problem. You're trying to classify. The dependent variable here is a what? Binary variable. Binary. So I'm going to specifically talk about binary logistic regression model. Binary itself basically means that wherever the outcome variable or the dependent variable is categorical in nature, I'm not started. So please you can just sit. I've just started with logistic regression. Take a seat, right? So wherever the outcome variable is binary, yes or no, whether a person is a fraud or he is not a fraud, whether a person will churn or he will not churn, whether a person will leave the company or not, attrition versus no attrition, right? Whether a person can be expected to suffer from COVID or not. All these things are classification problems. So logistic regression should be your go-to approach. That is the first approach when you are building a classification model. So the first point is for classification problem, you use logistic regression model. Second point is just like in the case of linear regression. This is also an example of supervised learning technique. Supervised learning technique, which means I need a dependent variable. If you give me a set of variables and then say, sir, you classify, I'll not be able to classify because there is no dependent variable at all here. Where is the question of classifying anything? If you want, you can have some water. Right, you can just, right? Are these 2 points clear? Right? When do I use linear regression? If the dependent variable is scale, use linear regression. If the dependent variable is categorical, specifically it has a binary outcome, then you can use logistic regression. In the industry, 80 to 90% of the problems that we solve are all classification related problems. Many times when we get customer reviews and such things, people say, find out the underlying sentiment. Is it a positive sentiment or is it a negative sentiment? Positive sentiment, that's a text, correct? Sir, your service is very slow. I called up the tele. Let's say I'm facing some issues with my ICICI bank. I'm just giving a rough example, right? So I call up the telecaller, right? She takes 10 minutes. It is not working, sir. She has given me a wrong link. She is not able to understand the problem. So I give a rating, a poor rating. Correct. And I say your service is really rubbish. The telecallers are not trained. They're untrained people. They're discourteous people. They don't know what they're doing. They're also not, helping me much. These are all words. Now, many times these words, people want to understand a simple question. Out of 10,000 people who have spoken, I'm one of the customers. 10,000 customers at the end of the month would have given a call to ICICI. As a bank manager, I want to know how many people are given a positive rating and a negative rating. How do I do this? In places like Mumbai, right? Not just in Mumbai, even in Bangalore, right? For a long time, what you used to have is you used to have a person who would read each and every word, and then he would manually classify this as positive rating. Second comment, negative rating. He would read it. 10,000 means 10,000 comments. He would manually do this. Right? And if it's a short sentence, they charge you around 16 rupees per comment. So 16 rupees into 10,000, you can just imagine how much is it? 1,60,000 if I'm right? So that is how much would be charged. If it's a lengthy sentence, it can go anywhere up to 25 rupees. 25 rupees per comment. And his job is to basically read and basically put this as positive comment, neutral comment, negative comment, neutral, negative. Now, this kind of business, market research organizations used to do a lot of these things. Annapurna Atta, we used to read these comments. People used to literally read these comments and basically they would say it is salty, not salty, texture is poor, this is good, that is good. We used to give a comment. And based on that, they would get a feedback. Oh, so many people have given a negative opinion. So many people have given a positive opinion. Now this change, the style itself is different. Now the thing is basically, given these ratings, classify this as a positive sentiment or negative sentiment. Positive is one, negative is another. Two, I'm predicting basically what? A binary outcome. First thing that should come to your mind is I should use a binary logistic regression model. Because the dependent variable has two outcomes only. Are you able to get this? So when you're predicting an outcome, which is binary, use binary logistic regression model. Now let's just try to understand logistic regression in detail. When can I use logistic regression model, right? I'm just giving you 3 examples, correct? In typically marketing kind of a scenario, right? And I used to work for an insurance company, right? I used to work, when I say I used to work for an insurance company, the client that we had, they were based off out of insurance, Aviva, right? They used to send a lot of campaigns. But when we inquired them, how do you send campaigns? You know what they said? They said we did just follow what is called as the spray and pray campaign. Spray and pray means you send a few campaigns and hope and pray God that somebody responds. In other words, they did not have a scientific mechanism to find out who will respond and who will not respond. This is the problem. Right, I was just now talking about business background, correct, with Nidhi. So this is the business background that they did not have a scientific mechanism. So that's why we said, boss, you give us your historical data. Based on your historical data, we will be able to tell you whether a person in future will respond to a mailing campaign or not. Out of 4 people here, if I find out that there are 2 of you who have a very high propensity to respond to a campaign, I will send a mailing campaign only to 2 of you, not the rest of you. So whether a person responds or no, yes or no, what kind of a problem is it? You are predicting a binary outcome. So use binary logistic regression. Understood? Secondly, in banking sector also it is widely used. Why? Because one of the main problems is to identify whether a person will default after taking a loan or whether he'll not default. Default or not. Again, you use binary logistic regression model. Third technique, right? Whether default we have covered, right? In terms of healthcare and such things, right? Do we use logistic regression? Exactly. They use logistic regression extensively because based on the patient characteristics, there you have BP level, diabetes, this, that, all these details you take and you try to estimate what is the propensity that this person will suffer from cancer. So if you're a healthcare professional, again, binary logistic regression will be widely used. Can you convert a linear regression problem into a logistic regression problem? I told you, right? If you know linear logistic decision tree and PCA, by and large, 90% of the real world problems you'll be able to solve. 90. Let us say we are trying to do price. He gives you a price prediction, right? The dependent variable, can I convert it to high and low? High priced Boston housing yesterday, last class we were looking at it. Those homes which are highly priced, and those homes which are low. High and low is what? Binary outcome. Now from a prediction problem, I've converted into a classification based problem. So many times when we don't get linear regression, we are not getting satisfactory results in such things. We are free, provided the client also agrees, saying that, boss, I'll convert this into high and low. Logistic regression problem you can't convert to linear regression problem, but ulta is possible. Linear to logistic possible, logistic back to linear is not possible. Okay, so these are the three examples or areas wherein you can use binary logistic regression model. Binary logistic regression is most useful with two outcomes. That's what I'm saying, right? When you have two outcomes, use this. Understood? Now, certain aspects of logistic regression that you need to focus on, correct? Now, I know that there's a lot of text here. We have already covered the first 2 points here, which is that's a supervised learning technique. It is used for predicting dependent variable, which is categorical in nature. Wherever you have yes, no, yes or no, 0 or 1, true or false. These are the areas wherein you can use your binary logistic regression model, right? Now, what is the key difference? This is a very good interview question. What is the difference between linear and logistic regression model? Any answers, guys? Any answer? Linear and logistic regression model, if this is crystal clear to you, right? What is the difference between linear regression and logistic regression? Half of the data science is clear to you, because then you will be able to propose, okay, this is the data set, I should use linear. This is the data set, I should use logistic. Scalable. Which one?
So linear we will use it for prediction, and logistic we will use it for classification.
Okay,
sir, if the dependent variable is scale, we use regression, and if it's categorical, we can go for classification.
Okay, anything else that you would like to say? Anything else that you would like to say? Both your points are absolutely right. Both of your points are absolutely right. For prediction problems, wherein you're predicting or estimating the outcome value, estimating the price value and such things, linear regression is appropriate, correct? Here I am finding out the class to which you will belong, correct? Logistic.
So, one more.
Please. I'm hearing, please go on, please go on.
Yeah, so one more reason could be, this is again I'm thinking, so it is like if the data is can be segregated linearly and the data is simple, and where you know there is, it is possible, I mean that as data is linear in structure, then probably we can use linear regression. But if the data is non-linear, okay, and then we can go for regression, right? So if the data is very complex, that time we can go for logistic regression.
No, not really. I'll tell you, I'll just clarify this point. First, I'll just try to give you 3 or 4 important points from an interview perspective. Tomorrow, if you're facing an interview on such things, this you should be very, very clear on this. Linear regression, prediction, estimating, housing price, estimating sales. Logistic regression, you're estimating, you're finding out which class a person belongs to, whether it's a defaulter or a non-defaulter. So usually it's a binary outcome. Secondly, the dependent variable is scale in linear regression. In the case of logistic regression, the dependent variable is a flag or a dichotomous variable. Thirdly, in the linear regression, when you are building a model, there is a 45-degree line. That is a graphical representation, correct? Y-axis you have, x-axis, and you have more or less a 45-degree line. That line is what is called as the linear line. In the case of a logistic regression line, you don't have a 45-degree line. What you have is a beautiful S-shaped curve. Are you able to understand this? You don't have a 45-degree line. You have a S-shaped curve. That S-shaped curve is called as a sigmoid curve. So we are using the sigmoid curve to model the relationship between a binary outcome and a set of independent variables.
Sir, one question here.
Please go on, please go on.
Yeah. So not necessarily it will be sigmoid all the time, right? It can be hyperabolic logarithm, or it could be ReLU. All the things are possible, right?
It can be. What did you say? Your voice is not very clear. Firstly.
Okay, it could be logarithmic, hyperabolic. I mean log h, or
No,
it could. Yeah.
No, it has to be sigmoid for the simple. I'll tell you why it has to be sigmoid. So we use a S-shaped curve or a sigmoid curve when you're building a logistic regression model, right? So these 3 points are clear. Fourthly, there is a change in the equation between a linear regression as well as a logistic regression. There, in the case of linear, we use y is equal to mx plus c. Here, when we are talking about logistic regression model, it is not y equals mx plus c. There is a change in the formula itself. The last and the most important point is, please remember, when you are building a linear regression model, the engine at the back end, the algorithm that we use at the back end is called as OLS, ordinary least squares method. Here, when we're using the logistic regression model, the engine is what is called as MLE method, maximum likelihood estimation method. Correct? So dependent variable, how is it changing? I told you. What is the purpose behind linear? What is the purpose behind logistic? That is clear. The equation y equals mx plus c, here I'll show what is the equation for the case of logistic regression. Then the next part is what? OLS and MLE method, maximum likelihood estimation method. And the model diagnostics, there we looked at R square. Here R square becomes useless. You should be crystal clear. In the case of logistic regression, usually people trick you and question you, saying, can we use R square? You should be very, very clear saying we cannot look at R square in the case of logistic regression model. That is not the way we diagnose the final model. There are other metrics. When you run a code, the code has been designed in such a way that it will give you R square. But please avoid looking at R square, because R square is not a reliable measure in the case of logistic regression model. So never report R square and such things to the client or to the interview or during an interview when you're talking about logistic regression model. What should you report? I'll just talk about that. Are these 5 points clear to you? Are these 5 points clear?
What is R square?
I'm not very clear because your voice is not very clear. Can you come again, please?
I'm sorry. What is R square?
R square you should not report in the case of logistic regression model. It is not a reliable metric.
No, I got that thing, sir. I'm asking, like, what is R square?
R square is coefficient of determination.
Okay.
R square is called as coefficient of determination. It is called as, it lies between 0 and 1. In the case of linear regression, it makes sense for me to talk about R square. Here I'm saying it is not a reliable metric. Are these points clear, guys, to you? Right? Right? If you are able to highlight this, trust me, you will be able to command a lot of respect in the eyes of the interviewer. Usually people do not highlight these things. I got this accuracy, I did that, 3 sentences, 4 sentences, right? So highlight the point that it is supervised learning technique. It's used for classification. What is the business problem that you're trying to solve? What is the difference between linear and logistic regression? Why did you use logistic regression? Even if he does not ask during the interview, you can say, so since the dependent variable is binary, yes or no, I was trying to build a model for whether a person will churn or not. So since the expected outcome is binary, therefore I did not use linear, I use logistic regression. Okay, so I hope these points are clear. Okay, a shape curve or a sigmoid function is being used as the fitting curve which gives output lying between 0 and 1. Okay, so let me just show you this. See, I'm just trying to sort of show this through a picture, right? I picked this up from the net. I didn't have too much time to work on the slides and such things, just to give you an impression as to how it works, correct? See, can you see here x1, x2, x3? Same concept as linear regression model. You have a set of independent variables, right? Now, certain weights and such things have to be determined. I've got x1, x2, x3. I will push it into the system. When I say system, linear or logistic regression model, the model will try to understand what is the importance of each of these independent variables. Are you able to understand? What is the importance of age in you being a defaulter? What is the importance of your income in you being a defaulter? What is the importance of your distance from office to home in you being a defaulter or non-defaulter? That variable is what that variable coefficient is what we want. Correct? But do you see a problem here? I will find out theta 1, theta 2, theta 3, which means basically what is the impact of variable age? Age, does it have a positive impact in a person being a churner or a negative impact? If age of a person increases, the propensity for a big person being churner increases or not? That's what I want. Correct? So similarly, second variable could be what? Income. Third variable could be marital status. Married people more likely to churn or unmarried people more likely to churn. So I want theta 1, theta 2, theta 3. This is what we need to estimate. Correct? So inputs, weights are there. And then finally, output is basically one of the two classes. Either I'm just showing you an example of happy or sad. It could be anything, default, non-defaulter, fraud, non-fraud, that kind of a thing we can estimate. Are we clear with this setup? Independent variables. But one problem here is when you take the multiplication of x1 and theta 1 plus x2 and theta 2 plus x3 and theta 3 plus x4 and theta 4. What is this? It's a sum product, correct? Sum, you're just taking the product and adding it. You can get any number, 1000 you can get, 1020 you can get, 10,000 you can get, minus 50 you can get, minus 500 you can get. How do you interpret that number? In the case of linear regression, it was simple. So this is the expected housing price. You take it or leave it. That's it. If I'm getting 5,000, this is the expected housing price for a locality with these characteristics. Crime rate is this much, percentage of black population is this much, lowest rate of population is this much, blah, 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 blah. This is the expected housing price. But in the case of logistic regression, if I get minus 500, how do I interpret it? Because I eventually want 0 or 1. Either you churn or you don't churn. Either you leave the company or you don't leave the company. Either you stay or you don't stay. Either a person will attrite or he will not attrite. Either the housing price is high or low. How the algorithm will spit out 500, 5,000, 10,000, 11,000, which cannot be interpreted in for our problem. Yes. So therefore, what we do is, can you see this S-shaped curve here? Everybody, are you able to see this? S-shaped curve. This is called as a sigmoid curve here. Do you notice anything important here? Anything interesting here? Huh? Yes. Threshold value and?
Threshold value.
Sorry?
Threshold value.
Threshold value, okay. Yeah, Pranish also said the same thing, okay. Anything else? Yes, exactly. When you look at the y value here, when you look at the y-axis, right? This sigmoid curve is a beautiful curve. It will not allow the sum product value to exceed 1, it will also not allow the value to be below 0. The moment I get that value of 5,000, I'll pass it inside this sigmoid function. What I will get is basically a value between 0 and 1. No matter what you pass, 500, 5,000, 50 million, this million, 80,000, minus 80,000, 800. So it's just a mathematical trick which I'm doing here, which is basically to pass this value within this S-shaped curve or a sigmoid function, and then that will do some mathematical jugglery. I'll just show you what is the motivation behind it. What it does is basically you may get a value of 0.8 or 0.3. If you are getting 0.5, do you see 50%, right? If based on my characteristic, if the model has estimated the value of 0.9, it means that there is a 90% chance that I default. 0.9 is greater than 0.5. Greater than 50%, I say that, okay, Mr. Mithun should be classified as a default, because there's a higher chance that he is going to be a default. Now, somebody else, let's say Aditya, he is getting a value of 0.1. 0.1 is less than 0.5. So since his value is less than this threshold, I will push him into 0 and say, boss, there's a greater chance of him being a non-defaulter. Are you able to understand this? So this is how your sigmoid curve will help you. Mathematically, when we get the coefficients, I'll just explain as to how does this work. Right? So this, we are going to use this function. We will not be using the linear regression model. The straight line wala thing will not help us here. Are you clear with this? The straight line is not helpful, so we have to use a S-shaped curve. So far we are clear. So you're following? Right? You're following everybody, right? So this is what I mean when I say we have to use a S-shaped form. So what is that mathematical formula, right?
Sir, one question.
Ask, please ask, please ask.
What is that weight in the two slide back? How the weight is associated with the input variables, and
Yeah,
what
so,
is its significance?
So those weights will have to be determined by the algorithm. So if you remember, I said that there's a algorithm that we will be using, which is called as MLA, maximum likelihood estimation method. That algorithm will try to estimate the weight by itself. So that initially when we get the data, I can't tell you what are the weights. Once I push it into the system and the algorithm learns the characteristics, then we will be able to estimate the weights. So that has to be determined by the algorithm. Right? For example, last class you saw in the case of linear regression, we got those beta values. The same way here, we will be getting the weights of each and every input variable, which will be determined by the algorithm. We have not yet built the model, so I can't show you the weights as of now. Is that okay?
Okay, sir. Okay, sir. Yeah.
So mathematical form of a logistic regression model is what I'm trying to show you. Can you see here? Right? This is what a sigmoid curve will look like, 1 divided by 1 plus e power minus x here. Right? Do you know what is the right side of your linear regression? Last class I showed you. In a linear regression, the right side of the linear regression equation. Y is equal to b naught plus b1 x1 plus b2 x2 b3 x3, correct? B naught plus b1 x1 plus b3 x3 plus b4 x4 plus b5 x5. The same thing, right, can be replaced instead of x also. Yeah. It looks a bit scary, but what this code is doing is basically that no matter what you pass inside this, you'll always get a value between 0 and 1. That is what it is doing, nothing else. Are we clear with this mathematical form? Yes. For a logistic regression, for linear, you know it is y equals mx plus c. So difference between linear and logistic regression, how it looks, I'm just telling you. Main difference is basically here in the case of linear regression, though it is saying 1 here, it can be 1,000, 10,000 in the y-axis. But fundamentally, when we talk about logistic regression, predicted y lies between 0 and 1, right? And here it's a bit difficult to interpret the coefficients also. Why do I say it's a bit difficult to interpret the coefficients? In the case of linear regression, when we got, what did we say? If nitric oxide content increases by 1 unit, right, housing prices will come down by 21 units. Do you remember? Minus 21 you had minus, so it is pretty simple, right? But here, can I make such a statement? Look at the graph here. So you look at the tail of this S-shaped curve, right? It is almost parallel. I'm saying almost parallel, not exactly parallel, right? So I can't say that 1 unit increase will actually bring down or bring up. It will bring down, that I can still say, but that quantity, right? 1 unit increase will in housing price will bring down something by 21%. That kind of a statement is very, very difficult because this S-shaped curve initially or at the tails, right, it is almost parallel. Then in the middle portion, it is increasing. Then again, in the mouth, it is almost parallel. So it is having different kinds of effect at different regions. And therefore, it's a bit difficult for me to say 1 unit increase in X will also increase or decrease the dependent variable accordingly. We don't interpret the output or the theta coefficients exactly the way we did in the case of linear regression because the nature of the curve itself is different. All that I can say is, boss, it's having a positive impact, it's having a negative impact. That's what I can say at best. Correct? This is the difference between linear and logistic regression, right? I've just sort of noted down some of these points here, right? This is important to you guys. Right, I've discussed this orally. You can just see here, what are we talking about?
Sir, can you zoom in a little bit?
Can you again ask yourself because you're not very clear with what you're saying? I'm sorry.
So in your display settings, please make it as a duplicate slideshow option.
Okay. That's what I have done actually. I don't know. Display settings.
No, not here in your PowerPoint. No, not here in your PowerPoint.
In my PowerPoint. Okay. Duplicate settings. Is it here? I have not done. Okay.
Sir, it's on the top.
On the top, you see, sir, show taskbar, display settings.
Oh, yeah. Correct. Duplicate, right?
Yeah, right.
Okay. So for any of your image classification systems, you can use this. Clear, guys? Shall I make a more? Step-by-step guide to build. Correct. You've already seen this picture. The steps as to how we sort of print the data, everything will not change. Model is now different because the mathematical equation is different. Generate the output, test data, model diagnostics. R square has been written, but please don't pay attention to R square. R square has got no significance. I should actually delete it. It is wrong for me to say R square because in the case of logistic regression, R square is not sensible for us to look at. I will delete it. I'm sorry. Okay.
So I have one question on the previous slide. Okay, so in the logistic regression, since we are saying the values between 0 and 1, and this is for classification, here does the classification mean which category a particular product belongs, or here does it mean like whether it belongs or not? Because when we are saying 0 and 1, between 0, if it is 0 and 1, then it is either 0 or 1. Because we are saying a value between 0 and 1, then we are getting into a multiple set of values, right? So
correct.
What is classification here?
So I'm just giving it. Can you see this picture here?
Graph? Correct. Yeah.
So what I'm saying is basically, when you use this logistic regression model, as you're rightly saying, I can get any value between 0 and 1. I can get 0.8, 0.3, 0.4, 0.5, 0.8, 0.91, 0.96, 0.981325, something. I can get anything. So what we are doing with those values is that we are putting a threshold here. So if that value is greater than 0.5, any value that you get is greater than 0.5, I will say I will put him in the class of 1. If that predicted value is less than 0.5, which means let's say 0.3, I will put him into the class of 0. So I'm going to say that the expected class for a person is that he's a defaulter because he has a higher chance of being a defaulter as compared to a lower chance of being a defaulter. Right? Eventually, what you will get is basically 0 or 1 because we are interested in the probability of the group membership. Which group membership do you belong to? Do you belong to the fraud case or the non-fraud case? Do you belong to the respondent class or the non-respondent class? That is what I will be getting eventually. That is what is our goal here. To identify which class do you belong to.
Okay. Okay.
Internally, there is it will also come up with some values to find out what is the propensity score and such things, but that is an intermediate step. But the final goal here is to estimate what is a person like Ganesh. Is he going to respond to my mailing campaign? If yes, I'll call him as a respondent. Or secondly, if he's not going to respond, I will call him as a non-respondent.
Got it. Okay. Sure.
You're absolutely right. So one more point here he's saying is basically logistic regression need not be binary. Yes, many cases the expected outcome need not be 2, it can be 3 or more than 3 as well. So for example, positive, negative and neutral. So if you have more than 2 classes, there's another type of logistic regression which is called as multinomial logistic regression. Right? Multinomial logistic regression model that can also be used. But here, the purpose of my presentation here is to focus on binary logistic regression model.
Okay, good, sir. Yeah. And also from the last week's thing, we also learned about the performance our model.
Yes.
So how is this different from the confusion matrix which we learned during the module 2?
Yes, yes. So here, exactly what we need is basically some of these names that you're saying, like confusion matrix. That becomes very, very important because we look at the confusion matrix to decide the overall performance of the model. There's also what is called as recall. There is what is called as F1 score. Then there is another metric which is called as we have recall, we have precision, and then recall, precision.
Sensitivity,
recall, precision, and F1 score. Sorry, recall, precision, and F1 score. These are the 3 additional metrics over and above the confusion metrics, which we can always look at. So when we did not do confusion metrics and such things for linear regression, that is not necessary there. Correct. Okay. But here confusion matrix becomes necessary because for any classification model, we look at the confusion matrix, recall, F1 score, and precision. Out of these 3, I would say you can focus on recall and precision more than the F1 score because F1 score is a derived metric. I'll also show you how to derive in today's class.
Okay, sure, sir. Yeah.
We have covered this. Model performance and diagnostics, you can see here I've mentioned some of the metrics here, like we can use any of these things. ROC curve some people use, it's called as receiver operating characteristic curve. F1 score also people use, but for all practical purposes, precision, recall, overall percentage of accuracy, these 3 things should suffice. Right? You can also obtain what is called as PR curve, which is nothing but precision recall curve. Right, this can also be looked at, but the 3 important metric could be overall percentage of accuracy, precision, and recall. This is as far as the diagnostics is concerned. I am nowhere mentioning about MAPE and such things. I'm not saying mean square error, R square. That does not come into picture here because R square and such things, are not reliable in this context. So far, are we clear, guys? What we are doing?
Sir, is there a scope to discuss little bit about ROC, F1, precision, recall, and sensitivity?
I will be talking about it. right? And when we come to that stage, I will just show you what is the formula behind this, when to use recall, when to use precision. We can just talk about it right now. I'm just giving the trailer here. This PowerPoint is just an introduction. It is just a trailer, so that you're clear with some of these terminologies and such things. When we are going to practically demonstrate, implement a logistic regression model, how to obtain each of these metrics, I'll just share the code as well as manually also I'll explain each of these things.
Okay, sir.
Okay. Okay, shall we take a small break and then come back and we'll continue? We'll just have a small coffee break, come back.
Yeah, sure, sir. Thank you.
Okay, guys, let me just show you a data set. I've shared this data set if I remember correctly. Just see this telco data set. Am I audible to you guys? And I hope you're able to see this data set.
Yes, sir.
Yeah.
Correct. So do you notice anything about this data set, guys? So we'll be using this data set to run a binary logistic regression model in Python. But do you notice anything? Do you get some thoughts, ideas about this?
Largely has categorical.
Yes.
Column S and T has continuous.
Okay. Okay. Anything else? Anything else? Guys, I've just, if you recall, this is the Boston housing data set, correct? This is the Boston housing data set. We had this, which is the dependent variable, and mostly I introduced only numeric variables. I did not take too much of string. So I could draw your attention to the concept of linear regression and such things. It was pretty simple because all the independent variables were numeric. Now here, what I'm trying to do is basically I've deliberately taken a lot of string data so that the data becomes messy, and in the real time scenario, you may have this kind of data. Nobody will give you just, on a platter all numeric variable. So this will give me an opportunity to tell you some of the pre-processing steps, most of the important pre-processing steps. Some of the important observations here, as you can see here, this is a telecom data set, right? People have been using telecommunication, right? So you have customer ID, not very useful for analysis. You can kick this variable out. Then you have gender, whether he's a senior citizen, is he living with a partner, dependents, tenure with the service, phone service, multiple lines, internet service, online backup, device protection, tech support, streaming TV, streaming movies, contract, paperless billing, payment, monthly charges, total charges, churn. These are some of the variables that we have. Correct? Now, can you see the last variable here, churn?
Sir, the last variable churn is categorical. So this will be a classification problem.
Exactly. Yeah, you're right. So firstly, let me apply a simple filter here, Alt DFF. So here, what are we trying to predict? See, there are two things that you could do here. One is, can you predict the tenure? Somewhere here, I saw the variable tenure, right? The duration of stay with you, correct? So this will be more like a linear regression model. So if you're trying to estimate tenure, what are the factors which influences tenure and such things? It will be linear regression model. The problem is not with estimating tenure. Here, I am focusing on estimating the churn, which is the last of the variables. Correct? So as you can see here, there are two classes here, no and yes. So this is my dependent variable. One problem here, do you see here? It is string, it is categorical plus it is string. So please be mindful of this. So these are the points which you should highlight. So basically, when you come to this, you can just highlight even your interview or something saying that we have to convert a string to a numeric. So there's what is called as a lambda function that you can use, or a simpler way from a machine learning perspective. What we say is a label encoder. So label encoder is what we will be using, and label encoder is used to convert a string dependent variable to a numeric variable. For dependent variable, we use this, not under all circumstances. Second problem. So remember that we have to convert this into numeric. That is one of the first steps. So this is how you should think. That's what I'm saying. When somebody gives a data set, what is the dependent variable? Yes, I've got binary, but that is string. So I have to use label encoder and transform this. That is one of the steps that I need to perform. Secondly, you can see here some of these variables are numeric. Am I right? Some of these variables which I'm highlighting in sort of green. Let me use a lighter green so that it's easy for you to visualize. So I hope this is better. Lighter shades, right? So, and tenure you can perhaps use. This also will be light green. So these are the variables which you can use as. These are numeric variables. They're not causing any problem to me. Am I right? Do you agree, guys? They're not causing much of a problem to me, so I can just work with them. The second problem that I would like to draw your attention to is there are so many string data that you have. You can see here all these variables which we are talking about. We have to find a way of converting these string variables into what? Into a numeric variable. So effectively, we have to take three steps. Firstly, your dependent variable, convert it into numeric, because machines understand numbers, they don't understand string and systems. Secondly, separate out the numeric variables. They are not causing you any problem, so leave them as it is. The numeric data part of it, the string data part of it, that you have to convert it into numbers. How do you convert? There is a beautiful function in Python which is called as dummy variable, get dummies. Using that, you can introduce dummy variables in statistics. But the problem with that is what? From 5 variables, you'll get 50 variables. Because if you have gender male and female, it'll create one flag for males 1010, one for females 0101. So we need to find a way of dropping some of these variables, right? We can drop, right? So ideally speaking, what is the right number of dummies that it should create? If you have 5 categories, 5 minus 1, 4 groups is what it should create. N minus 1. If you have 7, 7 minus 1, 6 dummy variables is what is sufficient for it. Otherwise, you get into a problem which is called as a dummy trap problem. Begin guys, one by one. Let me fire open some of the earlier codes and such things which I was just using. Let me just close all these things. Right. Trying too many things, maybe you can now close it all. Let me close this, all of these things, and open fresh. Let's open a fresh Jupyter notebook, guys. I hope you can see my screen, guys, everybody.
Yes, sir.
I'm just introducing a few cells here so that I can just directly enter a few codes. Let's begin with this. AI03, I hope, right? First, what we need to do is basically install all the packages, guys. Let's begin with some of these packages which we will be installing. Correct. Our old friends like NumPy, Pandas will still be operational. We need to do some pre-processing, right? Important metrics. You can see some of the accuracy related metrics, which I'm just calling out. Seaborn package. Train test split. How do you standardize? We don't need to standardize anything here, but
Sir, are you saying some? You're not audible.
Are we waiting for anything?
Uh, Sir, you are not audible.
What are you saying? Are you?
No, I think I'm asking like, are we waiting for anything? I mean, I saw the same screen for last some time.
So are you done with this? If you're done with this, we can just move on to the next. Just let me know in case you have typed this. Okay, done. Everybody. Okay, so here I'm just installing some of the packages. Okay, nothing else, right? So let me just begin by importing the data set. Right? You're already familiar. I have saved this file in our samples files. It's called as telco.csv. So this is my DF file. So maybe I can just type df.head of. So far it's clear. Right. So we've just imported this data set. Now, after importing this data set, the next thing that we will be doing is just check the shape of the data set. Let's explore this data set by checking the shape of the data set. So we have around 7043 rows and 21 columns. This is what we have. Just a simple shape command. Then after shape, the next thing would be to just verify the type.
Sir, can you send all the import file once?
Yes.
I think I'm missing one.
Sorry. I thought you had already completed it.
So I'm looking for all the import statements.
You're looking for the
Import statement, sir.
import packages.
Yes, sir.
Are you done with this?
Yeah, done.
Okay, we have checked the shape and such things. Next, what we'll do is basically we'll just look at the size. Basically, in the number of cells, it is just multiplying the rows with the columns. df dot head and tail, you can just see here. The first 5 rows as well as the last 5 rows here. So 7042s, this is what we have. The file size. Now let's just check if there are any missing cases here. Okay, first let's just type this function. So in pandas, there's a function which is called as is null, right? So pd.is null, I'm passing a data frame here, right? If you see here, we have saved the data set as df. When we imported the file, we have passed this as, we have saved this as df. So pd.is null of df dot any of. So what this does is basically it just gives me whether it is false, like that it gives me, correct? So if a particular column here has missing cases, we'll just highlight it by saying true. So I'm just verifying for missing cases here.
So df.info also will give that, sir?
Sorry?
df.info also will give the list of.
Yes, you're right. You're right. df.info also will give. If you want to just take the sum of the missing cases, you can just say this. Is null, right? We are going to use the function pd.is null, pass the data frame name, and we can just take the sum of missing cases.
So I used to make the mistake of putting sum next to is null whenever I wanted to look at the count. Okay, I think count, is it sum or count, sir? I mean, which is the right?
We are taking the sum of the missing cases.
Okay, if you use count, what happens?
I think you should be getting an error if I'm right.
Okay, so yeah,
entire sample
I think, yeah, it takes the entire sample. So this I used to do this mistake. Yeah.
Okay.
I have to remember it's sum.
It is sum, yeah, sum of missing cases. Sorry.
Mithun sir, sorry. So here when we are checking for the null values, so this false, totals are just false, payment method false. So false means there is no null values. That's what it is telling, right?
Come again. Sorry, I just tell me again.
So when we are checking for the null values here, it is saying customer ID false, gender false, senior citizen false. So it is saying in all those categories or features, there is no null values.
Correct. There are 0 missing cases. There are no zero null cases. Yeah.
Okay. And so
otherwise, if you see numbers like 10 or 13 or 14 here, let's say I'm just giving an example. Let us say for contract, tomorrow when you do, you get 10 here. It means that there are 10 missing cases in the variable contract.
Okay.
Right, so this gives you an idea as to which variable should you actually work on, because all of these variables may not have missing cases. So if you have 3 or 4 variables which definitely has missing cases, you might want to work on that.
So if there is missing cases, then if we don't want to drop it and if you want to impute some values, will we be doing it here? Yeah. Okay.
Yes. I'll show you.
Thank you.
I'll show you. Yeah. No problem. Sorry, you asked me something. Okay, so this is a very simple thing. In fact, what you can do is once you run this, you can maybe export this in Excel and you can just take the percentage of missing cases. Here, everything is 0, 0, 0, so it's fine. If you have 10 cases, 80 cases, 30 cases, 40 cases, 50 cases, 60 cases are missing, you can just take a simple percentage in Excel so you know for each variable what's the percentage of missing cases. So there's a variable which has missing cases like 25 or 30% of cases. At this stage itself, it is better to drop that variable. You can't get meaningful results by imputation and such things. Okay.
Sir, can I see the statement once?
This is the one, yeah. Just let me know if you're through with this. Yeah, we'll check that also because numeric it is reading as I know. We'll check that also. It's also.
So alternately, we can check like df dot is null dot sum.
Yeah, there are multiple ways of doing it. You're right. So either you can pass the data set inside the function, or you can use the data set name and then at the end you can attach the function. Okay. Now what we'll be doing is basically we'll be finding out what is the variable type here. Okay, we'll just be finding out what is the variable type here. And to do this, what Ganesh was just now saying, that df.info is a very good command base. df.info because it gives a lot of information. It just tells me how many non-null cases are there. As you can see here, 7043 non-null cases are there for each of these things. For each of these 20 variables, I'm seeing 7043 non-null cases. And it's also sort of giving you the data type. D type is basically data type. So object is there. Now integer and float we all understand. Now I'm just going to make a small comment here. Usually the word object can mean two things. One is basically an object is like a container. Here when you look at the data type and it returns the data type as an object. What does it mean? An object means that it is string or categorical in the below output. So Python is reading a few variables as string or categorical. For example, if you see here, total charges is being read as an object variable, right? The variable total charges is being read as an object variable. Total charges, if I go back to my Excel sheet, total charges, you can see here it is a number. For some strange reason, it is being read as a string variable. Maybe there are missing cases, maybe there are blank cases. I don't know. We have to verify that. But for all practical purposes, this will lead to a lot of problems. So we will get errors at a later stage. So wherever it says object, if it is a number and I'm treating it as an object, it's a problem. So we need to convert the data type. So one thing here is basically total charges. So let me just go back to Excel. Monthly charges, how is it reading? Monthly charges is float. That is not a problem. I've highlighted this in green. Tenure, how is it reading? Tenure is also being read as an integer, which is not a problem. So one source of problem here is basically the variable total charges. We want to convert this variable, this data type, which is being read as object into a integer or float. Now to do that, what we will be doing is.
Sir, I have a question.
Yes, please.
The total charges, there are blank values also. So when we fire the command is null or anything like that, which gives the missing values. So does not it consider the blank values?
Actually, I'm not very clear with what you're saying.
The total charges, when we do the filter on access tree, The total charges
in
column
Excel you put filter, is it?
Yeah, filter in the Excel.
Okay.
And in the total charges column. So we can see there are blank values also.
Are there
And
blank?
Yeah.
You're right, there are blank keys.
So when we were running the command is null, or when we were trying to see if there are any missing values, this column was not coming with number of missing values. It was coming just with the 0 and the false. So there are no missing values. How does it happen? Because the file which you have given, that car file. So for that file also, the same thing is happening. There are missing value, but when I was running the command, that sum of these or any missing value, it was giving 0.
So the Aditya also had the same question. Basically, does it detect blank cases? Right. So this pd.null function does not detect blank cases. That is only a simple message. So what we numeric, then it will detect, right? Right now it is not. Nidhi, one more thing is that if you see the data type of total charges, right? Let me just show you this Python. As of now, how is it reading? It is reading total charges as an object, correct? Now,
Yeah, correct.
what we will do is we will convert this object data type into numeric, and then we will rerun that null function and we will see whether it is able to detect.
Okay.
Okay. So the first thing is that this is string. So, okay. So let me just convert this. Okay.
Sir, I think the conversion should fail.
Yeah, because yesterday I was trying for the car, this file also. So it was reading the data, most of the cases object, but whereas the data was string, sorry, numeric. So I had to convert, put the NaN value, then, I mean, lot of pre-processing I had to do yesterday.
Okay, we'll find a way to convert this. Okay. One is basically, see here, let's firstly look at, I'll talk about conversion, just give me 1 second. Let's just run the describe function on at least the numeric variables. We know that total charges is not being read properly. So we will just run a describe function. It will give you the descriptive statistics for some of the variables. Like senior citizen, tenure and monthly charges, except this.
So all the numerics are considered in describe.
Yes. Right, total charges is definitely not appearing. The remaining variables are all read as categorical, which is a bit of a problem for us. We'll just work on that. Yeah. Okay. So one is basically the missing value imputation. This should fail. Correct. If I'm running a missing value imputation on total charges, see here, I'm just using this function fill NA df.total charges dot mean of. This should ideally return me an error, right? Because it is being read as an object, which is not an object. So let me anyway go ahead and execute this. It will return an error. Could not convert string to float. So what we will do is basically we will coerce that variable. We'll convert this into numeric, and then we will run this imputation function, right? So, but somebody asked me this question as to how do we deal with missing cases? If it had been a genuine numeric variable, if it is an int variable or a float variable, this should have imputed mean. But because total charges is an object, this gives me a value error. So what is the medicine for this? The medicine is basically convert this object into a numeric, which I will show you how to do. Let me just scroll down. Let me just scroll down. Right. Convert this variable into a numeric variable. So you can just use this function.
Excel, sorry, sir. Which value in the Excel currently we are seeing as a null value? I am trying to check in parallel.
No, there are blank cases, correct? Can you see? Okay, let me just give me 1 second. So this is how the data set was. This is the source data, correct?
Correct.
So I'm just applying a filter here for the variable total charges.
Okay.
In the filter, when I just scroll down for total charges, you can see there are blanks here, correct?
Okay, can you filter which rows? Sometimes like it may be taking below that also.
Shall I select only blanks and then click on OK?
Yeah.
So you can see here, these are the rows. There are at least 8 of them, which are basically blank cases. So when we run a pd.isNull off, so it is not detecting the blank cases. So which is the question which even Aditya had, does it even detect the blank cases? It does not detect the blank cases as such. Right?
So if it is a numeric, it will detect. That's what you are saying, right?
If it is a numeric, it will detect. You're right.
Okay.
If it is a numeric, it will detect. But firstly, because of the presence of these blank cases itself, it is reading it as an object.
Oh, because of the blank spaces, it is reading as object. Okay.
Yes. So it is not able to understand what do we do. So it is just put this as an object. So what we are going to do at this stage is basically, let's just come back to Python. Right. So pd.numeric, right? Convert the total charges to numeric. df.total charges error is equal to course. I'm just going to give it. So it will just forcefully convert this into numeric, except for those 8 cases.
So can you scroll up a little bit the previous line?
So this function, what I'm trying to do is I'm just trying to fill all these NA cases with mean. It does not work. Obviously, it does not work, right? So what I'm going to do is I'm going to forcefully convert this variable to a numeric variable using pd.to_numeric.
Yeah, but what is this output like? So when you're trying to take a mean, it is giving a big output.
Value error.
Okay.
Right. So you can just see here x is equal to float of x. It's not working. It's a value error firstly. I'm just showing this so that you know that it doesn't work. So here what I'm going to do is convert the total charges into numeric. Pandas has a function which is called as to_numeric. So I'm going to convert this variable total charges into numeric. Now what we are going to do is basically we can basically use the imputation method, right? Ideally speaking, this can come later also. OK. Is it taking it? Right. It should ideally be taking this now. Can we check the data type once again after coursing it into numeric? See, I'm just running the same df.info. Earlier, what did I get? See, when I ran a df.info, you can see here, this is displaying as float. 18th variable monthly charges is displaying as float. I'm sorry, not 18th variable does not have a problem. 19th variable total charges was being read as an object. Now what I'll do is I'll just rerun this df.info.
Hello.
Yes, please. Now you can see this variable total charges 19th variable. It is being read as a float variable. OK, it works for us.
Sir, do you want to use the imputation for the data sets that you give for assignment or maybe in the examination, or since the number of
See, you can just drop it because barely there are 1 or 2 cases, right? So you can just drop those cases.
Exactly. Yeah.
2, yeah. If it is just 2 cases, don't worry. But just so that if you want to practice and how it works, you can always experiment. Okay, just if you want to practice, it's okay. But 2 cases will not make much of a difference. You can just drop it. Right? So we are good.
Okay. Yeah, I got the answer, but thing is that if we are going to follow the imputation, then we need to know that should we using the medians or means, or like maybe binning or whatnot.
No, use mean by default. For all practical purposes, you can try mean.
Okay.
For all practical purposes, you can try mean, right? If you want median, I can give you the code for median as well. But for all practical purposes, unless there is a compelling argument for median, you can always go with mean.
Okay, sir, got it. So I was thinking that if you are more or less looking for values to be normalized, it's better to go for the median. I was thinking.
Usually, 99% of the cases when we impute, we use mean as imputation method.
Okay.
She wanted something. Sorry, you wanted to see the code? Is it? It's done. Okay, so far this part is clear, guys. Right? Object, it was being misread, missing values, right? We coased into numeric, then we use the mean imputation, right? Without that, without a string variable itself, it will not understand how to use the mean. So it will return errors, right? So far we are clear, Aditya? Right, very good. Okay, let me just make a move on. The next step here, right? Now let me just run the describe function. Again, I'm just doing this the second time. You can see here for all this int, float and such things, it will display, right? So it is in line with our expectation also. In the original Excel sheet, there are 4 numeric variables. These are the 4 numeric variables which I can separate out at a later stage. Done? Okay, it is giving me only basic statistics. Okay, next. So now we will be checking the distribution of the dependent variable, guys. Let us just check the distribution of the dependent variable. It can be yes or no. Yes or no. Ideally speaking, no. Logical. Ideally speaking, it should be yes or yes. We're just checking the distribution of the dependent variable, right? So if the number of cases of yes is very, very less, then no model will work. If it is less than 1% and such things. But if you see here, I think roughly 5174, and here I have got around 2000 cases, so approximately 7000 cases. Out of 7000 cases, approximately, roughly around 2000 cases are churners. So I think 2 out of 7 are churners. So I think we should be able to get a decent model, right? Okay, this now this comes, all this is part of pre-processing only, okay? We still do not have the base data ready, right? So we are just working on the independent variables, checking their data type, checking whether there is a missing case, forcefully converting it to numeric imputation, right? Now, this labels, if you see, it is no and yes. So for any and every model, this will be a problem because it is seeing a string data. It does not understand. So we have to find a way of converting this. This is where we have a good function which is called as label encoder. Right? For a dependent variable, we can just use this particular function. So converting from yes, no to 0, 1. So this is the next step we'll be doing it. We will be transforming the variable. Dependent variable we will be transforming, right? Specifically, we will just be transforming the dependent variable only. Pre-processing.label encoder, right? Earlier we had used the pre-processing, we had imported the pre-processing part. Now we are going to use label encoder, okay? le.fit df of churn. So this will access only the dependent variable. Okay, so this guy I'm going to transform. So what it does is basically if you have 4 categories, 4 minus 1, 3. Starting with 0, it will start coding 0, 1, right? So since we have 2 groups here, 2 categories, it will start with 0 and then it will end with 1. le.transform. Correct.
Sir, can you put a print before the list le.classes?
What do you want me to put?
Print a statement. I mean the list statement inside a print. Sir, this will not show any output. So you will have to put the print statements.
Yeah. After this we'll do it. First, let me just transform it and create the variable y. We can just, for display purposes, we can just view this df at a later stage. So I hope we are clear with this. Till here, we are clear, guys.
Sir, actually, Krishna was asking to put the print statement in the list command.
For this list, is this what you're saying?
Yes, sir. I really wanted to see the encoding, so I asked to put a print here.
The print statement.
Is this what you wanted?
Yes, sir. So this means, sir, it has taken no as 0 and yes as 1, right?
Yes.
Okay, so if that is the case, in this case, we are trying to find that who all have churned.
Yes.
And we are not bothering about who has not churned.
Yes, because they're harmless. So usually what happens is that in any binary class prediction, one class will be harmless. So for example, I'm just giving an example. Let's say healthy patients and non COVID patients. Healthy patients, they're usually not that harmful, and I'm not concerned about that. I want the model to learn the characteristics of one of the two categories, not both. Then the question may be, sir, why are you basically giving the other class? Why not just supply only the classes of COVID patients? The model will not be able to differentiate COVID from non-COVID. So you need to supply two. But out of the two, I want the model to learn the harmful category. In this case, I'm using the word harmful for churners. If a person has churned, why is he churning? What is the reason that is making him churn? That is the problem statement. Non-churners are not harmful, so I'm really not bothered about non-churners. Non-churners are not really harmful. They are anyway staying with me. They'll continue to stay. So out of two, usually we will not be worried about one of the classes. We will be worried of the harmful category in every problem. Lung cancer versus non-lung cancer. If a person is not suffering from lung cancer, no problem. I mean, can just carry on with his normal life as it is. But lung cancer, that is the category of interest to me. Okay, should we break for lunch now? Should we break for lunch?
Yes, I have, sir, one more small question. If this would have been a multi-class classification problem,
yes.
In that case, how would you code it?
In that case, what will happen is basically if you have 0, 1, 2, one of the categories should be called as the baseline category. And the model will be built for the other two. So for example, if you have three categories, let's say multi-class classification, let us say you have three groups, neutral, negative, and positive. I can take neutral as the baseline category and build a model for positive and and negative class.
Okay.
But there I will be using a binary logistic. I'll not be using binary logistic regression model. There, because the outcome variable is more than 2, I have to use multinomial logistic regression. So essentially, I'm talking about multinomial logistic regression, wherein one category should be considered as the baseline category, and the model will be built based on the other two groups. So I'm just giving a heads up here. There is what is called as SVM, support vector machine. There you have an option to specify what is called as one versus the rest. One versus the rest means basically if you have 5 groups, the model will be built in such a way that one of the things will be predicted. All the remaining balance 4 categories. If you have 5 categories, the model will be built for 1. The balance 4 categories will be treated as 1. So for different algorithm, that adjustment needs to be made.
I get it, sir.
So if there is a multi-class problem and you don't want to worry about which one is the baseline category, all these things you don't tell me, sir, give me a simple option, use a decision tree model. I don't want to treat anything as a baseline category. Just I want to understand the profile of each of these 3 groups. Take a simple decision tree model. It will give you the profile for each of the groups in the dependent variable.
Yeah. Sir, one more small thing. Say, for example, in this example, I would like to get the metrics for the people who are not churning. Then what I will do?
So just use inverse transform. So just as you have LE dot transform, what you can do is, let us say, I just wanted to show you this inverse transform as well. So you can use this function. Can you see this? LE dot inverse underscore transform. So wherever there is 0, it will put as 1. Wherever there is 1, it will put as 0, which means that non-churners, because that is the interest group that you have, that Krishna has. So we can code that as 1 and basically build the go ahead with the rest of the procedure. So the final interpretation and such things will be made for non-churners, not for the churners. So this is the code. The same label encoder will also use, gives you a function which is called as inverse underscore transform, which will basically do ulta of this. Wherever there is 0, it will put 1. Wherever there is 1, it will put as 0. So in general, as a thumb rule, just keep in mind that whichever class is of primary concern to you, whichever class is of primary interest to you, that you always call as 1. Then the rest of the interpretation, everything will be a lot easier for you. Whichever group you are interested in, call that as 1. The rest of the things you just call it as 0.
Thank you for clarifying, sir. So I was just struggling a lot with this, and I had to transform my data set altogether for this.
Yeah, I'm just not showing this because transform is there, inverse transform is there. I may confuse the audience. Therefore, I didn't put this up.
This helps a lot.
Sure,
so
sure.
It saves my time actually.
Okay, shall we break for lunch and come back later, guys?
Sure, sir.
Now it is almost 1 o'clock. Maybe by 2, shall we come back?
Sure.
Okay, sir.
Okay, sir.
Okay, thank you.